Hello everybody, and welcome to the Drydock episode 361. This week the questions are taken from Guide 429 to USS The Sullivans, the Wednesday video on the development of ASDIC and sonar in World War I, and the Friday video on LST 393 up in Muskegon. The man formerly known as Commenting Is What I Do asks, was there ever any concern about the security of steel mills when making armour? Trusting a private company with the formula for making a warship's belt armour seems like a rather easy way for that formula to be discovered by an enemy agent. Did the navies of the time just hope for the best, or were there any measures in place to try and prevent such compromises? It really depends at what point in armour manufacturing you're looking at. Essentially in the 19th century, yeah, you could in theory get some industrial espionage going on, but also in the 19th century, if you wanted the latest and greatest in armour technology from a specific company, you could just buy it. Unless there were some very, very, very strange or specific circumstances going on, armour would be sold either specifically to foreign countries or with ships that were then being sold to foreign countries by almost anybody. Once you get into the 20th century, much like with shells and propulsion and everything else, things start to get a little bit more closed shop as you go sort of the very late 1890s, then into the 1900s, and progressively more and more secretive until by the World War I period and interwar period, everybody's being very, very secretive about what they can and can't do with their armour. And at that point, yes, there are security measures in place, but in some ways, as the need for security increases, the companies in question, the steelmaking companies, they actually have their own interests at heart in securing their exact manufacturing techniques and formula. Because not only is it a matter of national security at this point, it's also a matter of financial security for the company. Because in at least the larger countries, you're going to have potentially multiple places that can manufacture armour plate. And which one of them is going to get the increasingly scarce, until the run-up to World War II, contracts for the manufacture of armour plate is going to depend very much on the level of quality control and the level of resistance offered by their armour. At which point it's not even, forget foreign influences, they're worried about other people within their own country coming in and discovering their secrets. So the companies themselves go pretty much into a kind of corporate intellectual property lockdown and are very, very careful about securing any technique or formula they have that they think is in advance of everybody else's, because they have a financial stake in the issue as much as they have a patriotic one. And so that actually serves to safeguard an awful lot of national interests, whether it be in armour manufacturing, gun manufacturing, or whatever else. It's just in the company's own corporate interest to keep those things secure. But there were, of course, also national level safeguards, what we would today call the security services, various kind of sting operations, and analysis by the said security services of people who might turn out to be enemy agents and whether or not they should be allowed to have access to certain information. And that was kind of across the board. I mean, in the case of X1, there was one particular person who tried to sell photos and plans of X1 when the British government was, at the time, wanting to keep X1 quite hush-hush. But he was fairly rapidly identified and was actually, in fact, already being monitored and was suspected of holding foreign sympathies by the security services, at which point he was apprehended. Although some photos did get into newspapers, he didn't manage to sell anything overseas. So you essentially had three layers of protection. You had the company which wanted to keep its own industrial secrets to itself. You had the national security services who didn't want things to get out to the enemy generally. And then a final layer was the fact that, especially as you got into the late World War I and then into war periods, the methods used to produce particular blends of armour and so forth were so esoteric that even if someone else got hold of them, unless it was something specific about how you alloyed the metal in the first place, you probably would take a while to modify your own setup to be able to produce the armour. You know, the chilling setup for controlling the depth of the face hardening and all sorts of things like that. As various technologies for making that began to diverge slightly, it obviously meant if you had a specific setup to do a specific set of armour in a specific way, you didn't have the opportunity to do it another way. And until you did a bunch of tests, you didn't necessarily know if the formula you'd gotten from your enemy was better or worse than yours. So worst case scenario, you might have completely reconfigured your armour manufacturing capabilities to make objectively worse armour. So they broadly, that kind of industrial espionage didn't really come off. Nix the Puppy asks, how would small navies choose what ship to buy or build? There are quite a lot of factors that go into this, but I'll highlight some of the bigger ones, and there are quite a few. So as I said, this is kind of just a highlights reel. Firstly, budget. How much can you actually afford? This will affect different countries to different degrees, because some countries can theoretically afford a very large navy, at least for their size, not necessarily a US or UK size navy, but they could potentially afford a substantial navy for a small power. They just choose not to. So in terms of money spent per ship design, if they need to spend a little bit extra to get more features, they can do. Whereas other countries, very cash strapped, they might only have a finite amount of money total, and that's all you're going to get. You can't argue for more because there just isn't any. Then you've got to look at special features unique to your circumstances. So what are you trying to defend? What are the surrounding waters like? And how are you planning to defend? One of the reasons we've got a Swedish destroyer up here. So if you're building a ship for Sweden, well, Sweden has lots and lots of islands and inlets to hide and duck through, lots of shallow water, absolutely loves mines, and has a bunch of shore batteries. All of that is going to affect the kind of thing you're going to design your navy to do. Also, operating in the Baltic, okay, it's not the smallest sea in the world, but you don't have to worry massively about, trans-Pacific ranges. Whereas, flip to the other side of the Scandinavian archipelago to Norway. Norway has a lot of inlets and so forth, but nowhere near as many islands and extreme shallows as Sweden does, although it's not exactly short on them. Has a much longer coastline, though, and obviously faces out into the North Sea rather than the Baltic. So, although they're very close, and although some of the environmental circumstances are similar, certain other parts of geography dictate that Norwegian choices for coastal defence vessels are going to be slightly different to Swedish ones. And, the Thai Navy from Thailand is going to want a different set of ships compared to the Scandinavians, and so on and so forth. Then you've got to consider infrastructure and where are the ships coming from. If you're buying ships from abroad, then the only infrastructure you really have to worry about is, do you have the infrastructure capable of maintaining the ships? If you're planning to build the ships in your own dockyards, do you have the infrastructure to build the ships in the first place? By inference, if you have the infrastructure to build them, you most certainly have the infrastructure to maintain them as well. But of course, construction and maintenance infrastructure costs more than purely maintenance infrastructure. Then what are you trying to defend against? What is the purpose of your navy? Is your navy there mainly as kind of a extremely heavily armed law enforcement, tax collection, and national prestige force? Is it there to deter and, if necessary, give a very bloody nose to a much larger, much more powerful navy that you fear might have territorial ambitions on your country? Or is it there primarily to act as a rival to another small navy, or multiple other small navies, which might be considered roughly peer opponents? And last of this edited highlights reel would be politics, because if you are choosing to buy either ships or systems from another country, that may align you or disalign you with other larger navies who may or may not then be more inclined to help you or more inclined to work against you. So, for example, Chile for a very long period during the Age of Steam and Steel, pretty much buys almost exclusively British. And that's part of a larger political strategy to align themselves with the British. Whereas you have Argentina and Brazil, who are their kind of rivals in the naval field in South America at this time. And Brazil obviously does buy a fair bit from the UK as well. Argentina, however, tends to try and buy from other places. And so Chile's looking at this and thinking, well, if we end up at war with Argentina, which to be fair is more likely than ending up at war with Brazil, by politically aligning ourselves with Britain, and that includes buying ships from them, it is more likely that the Royal Navy might come and help us, whereas the people that Argentina is buying ships from, and they buy from various people, including the US, in some ways, they're maybe hoping that the US will come and help them, but in other ways, it's also, as I said, a form of disalignment. It's as much about who you don't buy from as who you do that could make all the difference. And then you have people like the Greeks who aren't particularly interested in aligning or not aligning with anyone in particular until there's a real existential threat out there. But when the Georgios Avarov is being built, for instance, they essentially do a pick and mix of what they think are the best systems. So it's an Italian hull, but it has British guns, the fire control, the drive systems, etc., etc. All of these are basically them going, well, this country seems to do the best of that, so we'll have that. This country does this better, so we'll have them from there, to try and build essentially the best ship for their country. And also, because they've bought a little bit from everybody, theoretically, they're not aligning themselves with anyone in particular. Nikujaga Oishi asks, in the 1930s and 40s, for the 10,000 to 20,000 ton cruiser concept, in hindsight, was creeping up through the intermediate caliber main batteries, i.e. bigger than 8-inch but smaller than battleship grade 12 or 14-inch guns, really a good decision for countering treaty cruisers? For example, the 9.2-inch Royal Navy studies, the 10-inch guns on Ansaldo ships that were offered to Spain and the Soviet Union, or the 10-inch guns found on British proposals to Greece. Wouldn't it have been better to just stick more 8-inch guns on those ships instead, with protection against incoming 8-inch fire, especially if they might face numerically superior opponents and might need to engage multiple ships at once? The problem with these various designs is essentially they're trying to square a circle to a certain degree. They're trying to make cruiser killers, i.e. it's basically the mission role that the Invincible class battle cruisers were originally invented for, and it's not exactly surprising that they come out roughly the same displacement or a little bit larger. The reason they don't have the 12-inch guns of the Invincibles is because, well, they're actually, generally speaking, somewhat better protected than the Invincibles, with, 7, 8-inch, maybe a little bit more on the belt. And they are, of course, significantly faster, which is going to need more machinery. But the problem they face with their main armament is twofold. Firstly, yes, you do have this mission to potentially hunt down enemy heavy cruisers, but their other big mission, and which one is primary, which one is secondary, depends on who you ask, is to deal with the German Panzerschiff and a equivalent ship that they think that the Japanese are building. The Japanese aren't building it, but that's what they think they're doing. And so having lots of 8-inch guns doesn't really work in that paradigm. For one thing, the hull probably isn't going to be large enough to support substantially more 8-inch guns. You might be able to get 4 triples on there for 12 guns, but considering with something like this, which is in World Warships as the Gibraltar, it's Design 1 or Design A in one of the British design series, which has 12 9.2-inch guns by using quad turrets. Well, the 9.2-inch gun shoots further and hits somewhat harder, and this is a critical consideration when you're also having to deal potentially with Panzerschiff equivalents, because sure, having 12 or 15 8-inch guns means you can outgun an enemy heavy cruiser with 8-inch guns, but you're having to fight at the same range, and even if your belt armor is better, you could still take damaging hits to your non-belt areas. Whereas with something like a 9.2 or a 10-inch gun, you can engage outside the effective range of most enemy ships' 8-inch guns. And even if you're in the marginal range of an 8-inch gun, then your armour is going to be considerably more effective. And you can then also engage your Panzerschiff or equivalent at comparable ranges to their guns. So the enemy heavy cruisers or super heavy cruisers, whatever you want to call them, they don't have the advantage over you that they would do if you just went with lots of 8-inch guns. And likewise, it means that if the enemy is making a ship like a Deutschland, which has a decent amount of protection but not spectacular, with 9.2 or 10-inch guns, even at a decent range, you can punch through that armour, which then either makes the enemy ships considerably more vulnerable or forces them to significantly up armour for subsequent designs, which then pushes them well into the realm of true capital ships. And although the 9.2 and 10-inch fall a little bit into that unhappy calibre range, by the time you're designing these ships in the mid to late 1930s, to a certain extent, technology is beginning to allow you to perhaps get at least similar rates of fire as you would with an 8-inch gun. But it's not imposing the massive weight penalties that having a 12 or a 14-inch gun would for the hull size that you're looking at. Because these ships are also being designed with a fairly substantial anti-aircraft battery, they're now just about big enough to fit a decent underwater defense system on, and all of these things are eating into the weight requirements for the ship. So, essentially, if you were building a 15 to 20,000 ton ship purely as an Invincible type battle cruiser equivalent to take out treaty era ships, then sure, 12 or 15 8-inch guns, perhaps in 50 or 55 caliber models to give you a bit of extra range, would be viable, but they are being designed in a world where they're thinking that perhaps the Deutschland type Panzerschiff or Japanese equivalent may be far more prevalent and may be becoming far more prevalent than they're comfortable with. And so they have to be able to engage those ships on equal or better than equal terms as well, hence the larger caliber. Brendan Buersdorf asks, is there any chance you could discuss some of the late World War I German destroyer designs? They had some that were partially built and some that were never built that seem a fair bit more capable than their smaller standard torpedo boat classes, but I'm curious if there's any information on their displacement and armament figures to put some concrete evidence on their capabilities. At some point I do need to do a video on World War I destroyer designs. There's a reason I skipped World War I in the destroyer design lineage videos, and that's in part because while for the most part there are certain linear design trends that you can see pre and post World War I, during World War I everything is all over the place because you have designs competing left, right and centre, big, small, medium, plus ships that have been seized or ships that have been thrown together from spare bits and so forth. And so you don't have any kind of linear measure of these ships are getting bigger or smaller or whatever. It's just, well, this particular ship is twice the size of the previous one, but then the one that follows it is only 2/3 the size of that one, and all over the place. So I'm not going to go into massive amounts of detail about the various late World War I German destroyer designs here, but what I will say as an overall thing is that they have gone away from calling them torpedo boats and they are going over to calling them actually destroyers. And it's largely driven by encounters between German and British destroyers during the first part of World War I, where all other things being equal, the British destroyers tend to have an advantage because they're bigger, they're more seaworthy, they have more and or heavier guns, and this usually doesn't end particularly well for the German destroyers. They also tend to have slightly more torpedoes. And so in that sense, you could say that German torpedo boat destroyer design is a little bit behind the curve. They're just building smaller ships. Now, of course, they're building ships almost entirely for short-range North Sea operations, so you could argue perhaps there's some utility in more smaller craft. But, well, it turns out if you build a slightly bigger, meaner destroyer, it's a slightly bigger, meaner destroyer, whether it's in the Mediterranean, the Atlantic, or the North Sea. And so essentially what the Germans are generally doing in terms of the designs they're actually putting together from scratch, as opposed to the ones that they're adopting from stuff that they had under construction, some of which are pretty monstrous, especially by World War I standards, is they're essentially skipping 2 or 3 generations worth of destroyer development and going from their general design trend, which at the beginning of World War I, you're looking at a ship of around 900 tons, give or take a little bit in terms of overall displacement, normal displacement, because of course this predates standard, and usually armed with 88mm guns as standard armament, although some of them will later be regunned with 105s. They're kind of jumping from that to something of a sort of 11 to 1200 ton range displacement, by default armed with 105s, but potentially also armed with something like a 120mm, and they're even considering, basically speed running the way that German 1930s destroyers were designed, and even looking at 150mm guns, i.e. 5.9 inch. So what they're essentially trying to do is they're looking at the latest British destroyers, what will eventually become agglomerated into the V&W class, and going, those are the latest things we're facing. We want something that's better than that. So something of approximately similar, maybe fractionally larger displacement, with decent number of torpedoes and 3 or 4, depending on the design, much, much heavier guns than most of the German torpedo boat destroyer fleet has at the moment. And you can kind of see the difference, is why I chose this photo. Now, this is some German torpedo boat destroyers in the States in the post-World War I period, but essentially the first ship on the left and the second ship on the right, so the first and third ships if you're going left to right, these are your more typical World War I German torpedo boats. They're on the larger side of things for pre-war stuff, but they're more typical of the sort of 1913, 1914, 1915 German designs. And then the really big obvious one, the one that's second from left, this is essentially, roughly speaking, the kind of design the Germans were aiming on moving over to. So upgrading from the first and third ships to this second vessel, which kind of illustrates just how much of a jump they were looking at. And as I said, this was their idea of standardization. There were a few 2,500 ton-ish ships that were actually armed with 5.9 inch guns, but they weren't mostly part of the German design lineage for destroyers. They started off as based on ships that they were taking over, although there were plans for a production run of a small number of them towards the end of the war. So they were even speedrunning towards the slightly ridiculous overgunned ships that wouldn't disgrace their 1930s build program, but that was a little bit more on the periphery. But as I said, at some point I will have to go through all of these designs in a video where you'll get a lot more detail. Then I was recently reading a thread that was dedicated to discussing the possible consequences of a British victory and Irish defeat in the Irish War of Independence. I bet you that was a polite and well-reasoned discussion. One person on the thread made the proposition that with access to Irish airfields and a place called Cork, which he noted the Royal Navy has dearly missed ever since Irish independence, this would have done wonders for the Allied powers' early efforts against German forces in the Battle of the Atlantic, especially against U-boats. Would you agree with this assessment? So I think there is some worth in it, but it really depends on when you're looking at and exactly what you're looking at. So Cork, Cobh, I think it's called now, that would be quite handy for the Royal Navy in terms of ships and submarines, because it's about 180, 200 miles further into the western approaches than, say, somewhere like Plymouth. So obviously that takes a fair bit of time and fuel off of the steaming of especially the shorter ranged escorts, which are used to pick up convoys and take them out through the western approaches, which are the more dangerous section. Now, of course, there are U-boats eventually all over the Atlantic, but there's a lot more attacks closer to UK home waters. Essentially, you'd be extending the range of your non-transatlantic escort ships by about half a day's steaming, 12 hours or so, in theory, although in practice that would actually be more because, of course, you're going 12 hours steaming further west, but then you also don't have to come back 12-hour steaming. So essentially you're giving your escorts either a day longer at sea or a day steaming further reach, which would help quite significantly. In terms of air cover, I think this is where it's a sort of 6 of one, half dozen of the other as to whether or not it would be really effective or not. Now, obviously, objectively, it would be a bit more effective. It would extend air coverage a bit further. So what you can see on this map is 3 circles. So the 2 black circles, one is centered on Western Cornwall, the other is centered on Northern Ireland. And these represent, roughly speaking, the lower end of the ranges typically given for the Avro Anson, which was the most common maritime patrol aircraft in our RAF Coastal Command at the beginning of the war. Exact figures on the aircraft's range vary, but I've taken a lower end estimate of about 600 miles, because that then allows for it to be loaded down with weaponry and potentially also have some loiter time or some diversion time rather than straight out and straight back, which isn't really that helpful. And then in red, you can see the Anson's range if it was able to fly from Southwest Ireland. And, well, you can see over to the left, there's a reasonably sized chunk of airspace where the Anson can now operate, where previously it couldn't. So, obviously, ships in that area, and if you overlay where ships were sunk coming into the UK, there's actually quite a few ships in this area, that would have had some help. I think the larger reason that might have helped, though, is when it comes to closing the mid-Atlantic air gap. And you might think, well, hang on a minute, we've just established that we're only talking about a couple of 100 miles. How's this going to help? Well, that's a couple of 100 miles if you're just heading out into the western approaches. If you zoomed this out and you look at the full transatlantic situation, while there are relatively few short Sunderlands in Coastal Command at the beginning of the war, they and other aircraft like them do become more and more common. And if you take the range of most Sunderlands and you overlay that, you realise that a Sunderland flying from Western Cornwall or Northern Ireland can just about, if it flies essentially in a dead straight line, just about reach the easternmost points of Canada, which is why they have a mid-Atlantic air gap, because, you know, that's risky, bad weather, wind, navigation errors, all of that could leave you out of fuel, and it's literally just a point-to-point journey. It doesn't leave you any margin for carrying heavy weapons like depth charges. It doesn't leave you any margin for diverting off, circling, hunting U-boats, etc. It is literally just you will get there on fumes if you're lucky. Whereas if you take off from the southwestern part of Ireland, which is pretty much the closest you can get, then suddenly you can make it to somewhere like St. John in Canada with a few 100 miles in the reserve, in the tank, and the absolute eastern point of Canada, where potentially therefore you could put up a seaplane base or something like that, is far more reasonably within reach. You know, you've got hundreds of miles in the tank, which would allow you for both a safety margin and for, you know, carriage of weapons, diverting off to attack submarines, etc. It doesn't give you a huge amount of patrol time, but it would at least partially allow the mid-Atlantic air gap to be closed almost from day one, which would at least provide some deterrent effect and or potentially allow for targeted attacks on things like supply ships and so forth and critical U-boats in that period. As I say, it wouldn't be perfect, but it would be a fairly significant leg up. And I think the other thing would be, if that kind of transatlantic hop is now within a reasonable, if somewhat stretched range, then it might prompt either stronger calls for aircraft like the short Stirling or some perhaps other development, perhaps an ultra-long-range Sunderland or something, to be released to Coastal Command to allow them to close the mid-Atlantic gap far, far sooner than they did historically. Cold Warrior asks, "Hi Drac, in your opinion, how much did the success of Q ships influence the Germans' decision to go to unrestricted submarine warfare? Did the British create a situation which almost brought starvation to their shores unintentionally?" I don't think the Q ships really had a huge amount of influence on Germany going for unrestricted submarine warfare the second time around. In large part because, well, Q ships were around from pretty early in World War One. A lot of their successes actually come in the second year of the war, the first full year of the war, 1915, whereas, of course, the Germans go for unrestricted submarine warfare round two, the one that in part will contribute towards the US entering the war in 1917. In fact, although they're unrelated, if you want to play the sort of correlation equals causation game, the Germans actually step back from their first almost unrestricted submarine warfare campaign, not entirely, but almost, in mid to late 1915, right after the Q ships have their greatest success. So if you wanted to look at it that way, you could even argue that the Q ships actually made the Germans not do unrestricted submarine warfare. That's not actually the case in any way, shape, or form. It's just an interesting random correlation. I think the only way that you could potentially draw at least a tangential link between Q ships and full unrestricted submarine warfare in 1917 would be as a sort of a secondary or tertiary contributing cause, in as much as the presence of Q ships was one of several factors that, as the war went on, caused the U-boats to move more and more towards fully submerged torpedo attacks on ships, as opposed to earlier in the war where, due to a combination of wanting to save ammunition, not having many torpedoes on a lot of the early U-boats, and wanting to follow cruiser or prize rules, they tended to surface and go after ships with their deck guns rather than their torpedoes whenever possible, save the torpedoes for either big targets or warships. And as I say, it's not just the Q ships that tend to force the Germans to resort more and more to torpedoes later on, but having to resort more and more to torpedoes means that you have less overall ship killing power, because of course if you can stop and kill a lot of ships with your deck gun and you have your torpedoes, you can sink more ships. Therefore, if you are trying to make the various calculations in 1917, one of your calculations might be, well, how many ships can we reliably expect our U-boats to kill? And if that number is capped by your number of torpedoes aboard, then, well, if you're going to haul those heavy things all the way out there, you might as well make maximum use of them. And if you can make maximum use of them against anything and everything, that would be a small influencing factor. Whereas if you could target British shipping specifically in a more discriminate manner, well, that would require you to be on the surface and you could use your deck guns. But it would be that's a very, very weak link. You'd have to kind of squint and look at it sideways. So broadly speaking, I don't really think the Q ships have all that much, if anything, to do with the Germans going to unrestricted sub-warfare 2 years after the Q ships have seen their heyday. Reading Railroad Fan asks, as a civil engineer, I understand modifying designs and engineering plans to make things work, but I have always been confused in terms of ship design how ships of a single class can differ so dramatically in length and displacement, excluding refits or additional weaponry. Well, I think really you've got two potential causes of this. On the one hand, you have a sort of deliberate drifting of the design, and this could be where you're building maybe only one ship of a class at a time, or if you're building more than one, it's low numbers, so you're laying down ships at slow intervals, and by the time you're halfway through the class, the first one's already been launched or is even in service. And at that point, the temptation, or perhaps the need to tinker with the design and modify the hull form here, or add an extra gun there, and so on and so forth, in response to either issues identified with the first ships in the class, or just a general desire to improve the design in light of new technology or potential enemy opposition, will result in designs creeping higher and higher and higher. Probably the absolute top example of this would be the Hipper class, because if you look at the original Hipper, she's 665 foot long, roughly speaking, at the absolute extremities, although that gets a little bit longer once you stick a clipper bow on her, but that's the original, and a displacement of a little bit over 16,000 tons. But the last in the class, Seydlitz and Lutzow, before that name is taken off for one of the Deutschlands, they are probably going to be 25 foot plus longer and a couple of feet wider. And they've added about 1,500 tons in displacement, i.e. the weight of a medium-sized destroyer, to their overall displacement. And yeah, at that point, most of the time you'd call those a subclass, but there are so few hippers, and because you have obviously Hipper and Blücher at the beginning, then Prinz Eugen, and then Seydlitz and Lutzow toward the end of the production run, they end up being stuck into the same class. Although, of course, the other thing is Seydlitz, for example, not originally supposed to have twin 8-inch guns, and then they tried to turn her into an aircraft carrier. And at one point she was also supposed to have twin 8s. It's all a bit of a mess. But anyway, that's one example. It's just design creep over time, with there being about 2 years between the laydown date of the first and last of the class. But the other way that you can end up with ships of different length and displacement, even though they are ostensibly all being built to the same design plans, simply comes down to variations within shipyards. Because every shipyard, and potentially even crews within a shipyard, have slightly different ways of doing things. And you've got to remember that building a warship is, especially back then, more a case of assembling lots and lots of parts of a gigantic lethal jigsaw puzzle than it is going, here is a standardized part that is X meters or feet long. And a lot of it can be made up of actually really small individual changes that just happen to add up overall. So, for example, when they're laying down the keel, some people might put 1/8 of an inch between the individual members of the keel when they're plating them together. Others might put 1/16 of an inch. There's just random examples. I'm not necessarily saying specific shipyards did exactly that. But once you add up all of those little amounts in terms of difference in gap between plating where it's either being riveted or welded together, or beams or whatever, then over the length of a large ship, that might add up to a number of inches. Or when you're spacing out the frames, let's say, someone might go, okay, we're going to space the frames out going from center of frame to center of frame. Another yard might go, we're going to go from edge of frame to edge of frame. Still another might go from center of frame to the edge of the next frame. Now, those are somewhat extreme examples, because at that point you would end up with a drift in length between ships of multiple feet, which people might notice. But most of the changes that you're going to see are going to be these kind of, what appear to be on the surface, relatively small differences in how things are built per yard, which then all add up, because, any one of those changes is not going to make a huge effect on the local work. People are just be like, okay, well, here's a whole plate. We're going to final cut it to exactly this size because, well, that fits on the frame widths that the previous guys in the yard have set up. Whereas, next door, they might be just that fraction shorter, but between overlapping plates for riveting, or the width that you fill in with welds, and the fact that you're not necessarily going to get perfectly cut plates into the yard anyway, you're going to have to do a little bit of trimming. No one's really going to notice until someone takes a tape measure out and goes, hang on 1 minute, why is this ship 3 foot longer than that one? And similarly with things like displacement, you might get a batch of armour that, let's say your armour tolerance on a capital ship is plus or minus 1/4 of an inch. If you get a bunch of armour that's been cast and pressed and has come out just a fraction under, let's say someone said we want 14-inch armour, and this lot's come out at about 13.8, and then the next battleship that's being built to that spec, they've perhaps slightly overdone it with the armour and had to mill it down, but they've milled it to 14.25 inches. Well, now you've actually got 1/2 an inch of difference, and across the area of armour, that adds up to a fair bit of weight. And weight-wise, you can have other things like, one ship's electrical system might run with all the cables pulled nice and taut and wrapped nice and neatly. The electricians might leave a little bit of slack in them, but that little bit of slack, an extra inch or two of cabling per 10 yards or something, add up by the miles and miles and miles and miles of cable inside a ship. and suddenly the cabling on one ship weighs a few more tons than the cabling on the other ship does. Add all of these differences together and you get a wide range of displacements. And those are just some relatively easy examples. These days, there is still some variation, but of course, the somewhat higher precision nature of a lot of modern shipbuilding means that the differences tend to be somewhat less, usually at least. Richard Goldberg asks, could you explain the Japanese doctrine for deploying carrier air wings? I've seen a little bit on this subject, but I'm referring to some carriers being dive bomber experts and some carriers being torpedo bomber experts. Pre-war, it was a mixture of natural evolution and luck of the draw, and then during wartime, you had the additional element of American fighter pilots having a bit of a vote in matters. So I think one thing people sometimes forget is that although the Japanese carriers aren't at war as in a World War II scale of war against a peer opponent, until the end of 1941, they have a long ongoing commitment to the Japanese war effort in China for a considerable amount of time before December 7th, 1941. So they do have their pilots and therefore the air groups racking up a certain degree of experience. Now, the slightly random nature of things is, of course, some pilots turn out to be really good at dive bombing, some pilots turn out to be really good at torpedo bombing, some pilots are really good as fighter pilots and so forth. And even under the very strict regimen of Japanese fighter and strike pilot training, you will end up with some pilots who are particularly good at their chosen profession agglomerating into particular squadrons on particular carriers. So that gives you a kind of a little bit of a natural boost. If you've got 3 or 4 really good, let's say, torpedo bomber pilots on one carrier and 3 or 4 really good dive bomber pilots on another carrier, you're going to start to see a little bit of a drift towards those specializations, because obviously as training goes on, those experienced pilots will be able to either lead by example or pass on their lessons in other ways to the other pilots in their units. Plus, with this war in China, if, say, Cargo goes out and does a whole bunch of dive bombing missions, that's operational experience for her dive bomber pilots. Therefore, her dive bombing unit is going to become much better. But if, say, for example, there's a carrier battle where a lot of Val dive bomber pilots get shot down, but not as many Kate pilots get shot down, and let's say both groups suffer casualties while attacking an American carrier unit, well, then you've got a larger surviving element of torpedo bomber pilots. Therefore, by the time the air group has been reconstituted and they've gone through training and so forth, the torpedo bomber unit in that carrier is going to be significantly better at its job than the brand new dive bomber unit that doesn't have any combat or operational experience on the same carrier. And of course, this is all going to change as the war progresses and different units take different levels of casualties or are deployed to different areas or given certain amounts of intensive training. And to a certain extent, especially in the early war, when Japan actually had a fair number of carriers and pilots, there's also a little bit of natural reinforcement, because if you know that one carrier's air wing is particularly good at dive bombing, then if you've got a mission that's going to need a lot of dive bombing, you're probably going to try and use that carrier. Whereas if there's another mission that perhaps needs more torpedo bombers, and you've got another carrier that's good at torpedo bombers, well, you're probably going to prioritize that carrier for that mission, thus gaining more experience, and thus ever improving the capabilities of that unit, assuming it doesn't suffer massive casualties. Brad in SoCal asks, thinking of the recent tragedy in New York with the Mexican tall ship training vessel backing into a bridge, in the age of sail, how did sailing vessels get into a wharf and back out safely? A combination of factors. Part of it is, well, when everyone has big tall masts, no one tends to build gigantic bridges that are lower than the mast heights of those masted ships right up close to where you're going to have those ships docked. I mean, to be fair, in the age of sail, people weren't generally building massive bridges like that anyway, simply because the technology wasn't there, but that's a slightly separate matter. This, incidentally, is the British fleet off Cherbourg in 1858, in case you're wondering. Now, there are a few other factors, and one of the reasons I chose this photo, apart from the fact it's one of the earliest actual photos of British warships, And as you can see, these British ships are in Cherbourg. They're inside the harbour, but they're not at a wharf because the big ships, one of the key ways that they managed to get to wharves and back out safely was not going to those wharves. You just anchor offshore in more open water where you can more easily manoeuvre and send your ship's boats ashore, or have small harbour packets come out to give you supplies and to take men ashore for leave. Another way of doing it was tugs. Now, of course, in the late age of sail, you can have actual steam tugs. Obviously, this being 1858, you can see the little paddle ship down there on the right-hand side. But even before that, there was a limited tug service, and this could be made up of, to a certain extent, triangular 4.5 sailed ships, which could maneuver more readily in the wind, but usually it would just be made up of the ship's own boats and a bunch of local boats with oars to help maneuver the ship around. But obviously there was a limited amount they could do in particularly contrary winds. But that could help for getting a ship in and out of the slightly trickier spots right up next to land if they were on a wharf or pier side or something like that. And the final thing was, of course, this fleet does have auxiliary engines for the most part, but for most of the age of sail they don't. And so when they are going to set sail, they either just wait for a complementary wind, because that'll take them in the direction they want and not back in the direction of something they might run into. Or if they can't wait for whatever reason, then they would either tack their way out very carefully, or they would kedge their way out, and various other methods or various names depending on which navy you're in. And that basically consists literally of just having some of your boats out there. You send a boat ahead of you with one of your anchors aboard and run it out as far as the cable will go, drop the cable, and then your men on board with the capstan literally winch the ship over to where the anchor is, and another boat will be doing the same thing with one of your other anchors. You bring that first anchor up, and essentially you're hauling yourself along on your own anchor cabling. Patrick Donnelly asks, does Task Group 38.4, Franklin Enterprise and Friends, attack on the Japanese Navy's southern force count as part of the Battle of the Sibuyan Sea? It really depends who you ask, because the attack on the southern force does occur on the same day as the Battle of Sibuyan Sea, 24th of October, and it also is obviously done by some of the same carriers as are involved in Sibuyan Sea. However, under a very, very strict definition, the Battle of the Sibuyan Sea is an engagement, shockingly enough, in the Sibuyan Sea against the Japanese Centre Force, whereas the attack on the Southern Force happens in the Sulu Sea, which is nearby and not related to the helmsman of the NCC 1701. But because of the proximity of the two incidents, sometimes it is grouped in as part of the overall Battle of the Sibuyan Sea. Sometimes it's mentioned just as a standalone attack. Ultimately, not a huge amount of damage was caused, some, but not much. And so people are just like, oh yeah, this also happened. Some people classify it as its own little engagement, the Battle of the Sulu Sea. And Naval History and Heritage Command call the whole 24th of October thing the Battle of the Sibuyan and Sulu Seas. So I guess you can take your pick, really, depending on how highly you rate the attack and how much relevance you think it has to the rest of the ongoing engagement. Nosdormu89 asks, I know at least one of the Kriegsmarine's U-boats made it to the Pacific and did carry out some operations, and some made it to the Indian Oceans. What can you tell us of their ventures and the impacts of these? So really, for this, we're kind of looking at the U-boats in the Indian Ocean, because, U-boat impacts in the Pacific are basically negligible. But U-boat impacts in the Indian Ocean were a little interesting, actually, because you have two broad ways of doing this. Firstly is sending long-range submarines all the way down through the Atlantic, round the coast of South Africa, and back up into the Indian Ocean, mostly then operating off the east coast of Africa. This is done usually a bit earlier in the war, where they can rely on Hilfskreuzer and supply ships to help maintain the U-boats. And then as time goes on, you get the Monsoongruppe, based over in Penang on the eastern side of the Indian Ocean, and therefore operating mostly on the eastern side of the Indian Ocean. And you can see some of their submarines here with a Japanese submarine doodling along in the background. Now, they do have a fairly decent impact on a per-sub basis, but this is mitigated by the fact there aren't that many of them, because obviously the Allies aren't really expecting particularly heavy enemy submarine activity in the Indian Ocean, because it's so far away from Germany, and Italy for that matter, given that the Allies control the Suez Canal. And while the Japanese submarines do sometimes sweep through the Indian Ocean, as we've covered many times before, the Japanese submarines are generally far more obsessed with trying to hunt down warships than merchant ships, so the Japanese subs don't have nearly the same impact on Allied shipping as German U-boats, which are usually fairly specifically going after merchant shipping, do. The flip side of their effectiveness, because of the minimal amount of escorts, is that sooner or later the number of ships they're sinking do force the Allies to actually devote more resources to the Indian Ocean, both in the form of convoys and in the form of sending in additional escort vessels. And while that does occupy Allied attention for some time, and for a while they don't have enough escort vessels for what they do want to do, the simple fact of the matter is there are never quite enough U-boats out there in order to really heavily tip the balance. And as Allied escort and convoy efforts improve, then obviously each target becomes harder and harder for the U-boats to find, and their kill ratios start to drop to more like something you'd expect to see in the Atlantic, as opposed to the relatively free reign the early U-boat operations in the Indian Ocean have. But they do occasionally cause a fair bit of trouble, because their operations, combined with Japanese submarine operations and the threat of Japanese surface warships, does occasionally force the Allies to either back out of completely or partially certain portions of the Indian Ocean, again simply because the resources aren't there to construct a major challenge just yet. Towards the end of the war, obviously that changes, but in late 42, 43, in even early 44, occasional upswings in the combined Axis submarine operations and threat of Axis surface shipping does mean that some shipping routes, particularly in the northeastern part of the Indian Ocean, are almost abandoned or shut down for risk of those ships being lost and there not being enough resources to completely safeguard them. It's one of the major problems, actually, when it comes to the Bengal famine, because obviously one of the ways to try and mitigate it is to ship food into Bengal, because the place you'd normally get food to mitigate a famine in that area is currently under Japanese occupation, and, well, the Japanese aren't sending any food supplies over the front lines, shockingly enough, but the threat and the actuality of Axis anti-shipping operations in the Bay of Bengal is such that it's not seen as worth sending in a lot of those ships until enough escorts and convoys can be sorted out, simply because, you might send in a dozen ships fully loaded with food. There's no guarantee any of them will actually get there, at which point you haven't actually solved anything except losing a bunch of ships that you can scarce afford to lose and their cargo with them, which obviously then isn't going to feed anybody except the fish. Hark asks, let's say that humanity never somehow managed to domesticate the silk moth, and thus silk is not available. How does this change the design of naval artillery if the propellant bags can't take advantage of the great characteristics of silk? What alternatives could there be other than very large cartridges, maybe? Did anyone try to develop a substitute for silk in the time that the channel covers? Well, actually, we can look back in time to the beginning of cannon-armed ships in the Age of Sail, because in the 1500s, early 1600s and so forth, silk was still an incredibly luxurious thing to have. There was no way people were going to be using it on, just filling random bags of gunpowder to be blown out of cannon every so often. And so, for example, when you look at the Antony Roll, the Tudor warships, you get a mention of two types of material being used for cartridges, i.e. bags of powder for use in the cannon, or the guns more accurately, because a cannon was a very specific type of naval artillery at that point, and that is paper and canvas, presumably a light canvas. Now, of course, paper is more useful for cartridges on the smaller end of things. Perhaps you could probably still use a decent type of paper for most of the age of sail, but once you get into the really big guns in the late 19th century, World War I, World War II, paper's probably not going to cut it, so you're going to be probably looking at canvas or some variation thereof. Now, of course, these things aren't going to burn quite as cleanly as silk, but that would mean a greater increase in things like bore evacuation and even worming and scrubbing out the gun barrels, at least early on. Once you get into the really, really heavy naval artillery, that's not so practical. You're looking more at bore evacuation mechanisms. But the other thing that you might see, at least to my mind, would be that from the late 1880s, early 1890s onwards, you might see self-combusting bags, not in terms of it just burns really well, but it is specifically actually a kind of explosive. Now, this would mean, of course, that you would have to have somewhat more stringent casings for the charges while they're in storage in the magazines, because, of course, silk itself is inert and doesn't explode, whereas nitrocellulose, which is what I'm thinking of, very definitely would explode, or catch fire at least, and then cause its contents to explode. So you would need somewhat sturdy charge cases, but it would be entirely possible to do, because if you've ever used flash cotton, then you know it burns pretty cleanly and without much of it in the way of residue. And if you can make gun cotton, you can make nitrocellulose fabric, and if you can make nitrocellulose fabric, then in theory you can make your charge bags out of that. And as long as you make it in such a way that it's relatively stable and doesn't degenerate and set itself on fire randomly every couple of years, then you get a very, very, very marginal increase in power, because you're getting a little bit of extra energy from the burning bag. But more to the point, you'd get near complete combustion of said bag, thus replicating the overall effects of silk charge bags, albeit at a somewhat higher risk. Gunnery officer asks, what would you do to fix the vibration problems on the North Carolina class battleships? If these problems are fixed as early as possible, do you think they'll be ready for action by December 41? Do you think they'll be screening US carrier task forces in 1942 hit-and-run raids? Honestly, without using future knowledge, I'm not sure that you could fix the vibration problems on the North Carolina class much sooner than you did historically. I mean, theoretically, you could really luck into exactly the right combination of different propeller blade counts and sizes very, very early on, and thus get the shift of the vibration point down to the high teens of knots, where you don't really tend to travel for very long, and thus get your ships into service sooner. And if you did that, then yeah, you probably could get at least North Carolina ready for the end of 1941, considering she technically commissioned in June. So that could be done, but I don't actually really think you'd see them screening the US carrier task forces in the early hit and run raids, partly because they would be far too valuable, and partly because they'd actually be limiting the task forces, because they can only do 28 knots at a push, and the cruisers and the carriers can go 3, 4, 5 knots faster than that. And given that these are real hit and run raids and they're worried about being caught by the Japanese, having that additional speed is probably far more useful than having a random fast battleship there at that stage in the conflict. So I think they'd probably just still be in the Atlantic for a bit. And this actually kind of harks back to a question in a previous Drydock relatively recently about what you can and can't test in towing tanks on scale models. And this kind of vibration issue is actually one of the things you really can't test, because the harmonics that cause the vibration, they have a fixed wavelength. And it doesn't matter if you scale the ship up or down, those natural frequencies and their wavelengths don't change. So If you have a 1/10 scale North Carolina, the frequency doesn't downshift by 1/10. It just remains exactly what it was, and therefore you're not going to have that vibration problem. Now, you might find some other natural frequency issues with your model, but they likewise won't apply on the full scale version. So unless you're very, very good at calculation, and computer modeling obviously is not really a thing in the 1930s, this is the kind of thing that will unexpectedly come up and bite you unless you've happened to have some random prior experience with the problem before. And the only real way you're going to solve the North Carolina's issues really is to remove the skegs and just have propeller shaft props or struts instead. But that has two problems. Firstly, the US Navy really, 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 really likes its skegs. And secondly, they do actually form a structural part of the ship, so deleting them entirely is, shall we say, not a brilliant plan. So, and that's assuming there is going to be a problem. So realistically, with the knowledge you have available at the time and what the US Navy will let you do, about the only thing you can do is hope to get lucky with those propeller combinations, as I said earlier. And finally for this week, Nathapron Hongcheron asks, did the Nelsons have stability issues caused by having all the turrets really close to their centre of mass? A Japanese language video I found mentioned that as one of the main reasons for the Yamato eventually having a normal gun arrangement. No, there's no indication that I can find that grouping all of the turrets the way they did with Nelson and Rodney caused any stability issues. In fact, if anything, Nelson and Rodney were known for being quite nice, stable gun platforms. The lightweight of the decks notwithstanding with the amount of damage the guns could do to their own ships, but that wasn't a stability problem, that was just a strength of construction issue. But one of the things you've got to remember is that once you factor in the 18.1-inch guns, each of Yamato's turrets weighs about twice as much as each of a Nelson-class's turrets, at which point, if you're making design considerations for stability, well, regardless of the fact that Yamato displaces about twice as much as a Nelson, she doesn't have twice as much beam, she doesn't have twice as much freeboard, she doesn't have twice as much draft, at which point sticking the equivalent of 6 Nelson-class turrets almost, stacking on top of each other in the middle of a Yamato hull, that could conceivably cause a lot more stability issues despite the layout being the same than the Nelson's layout could. The other thing you've got to remember is that for a number of reasons, including wanting to have a large deck to operate aircraft from and a very heavy secondary battery and additional machinery because they're supposed to be going in the upper 20s of knots, the all forward gun Yamato designs, although the overall layout is similar to the Nelsons, the placement of the guns is not quite the same as the Nelsons. So if you look at a Nelson-class silhouette and you split it down the middle, looking at it from the side, you'll notice that that line goes near enough as makes no difference straight through the aftmost of the main turrets. If you do the same thing with the Yamato all-forward layouts, you either end up going straight down the superstructure or down the very back end of the aftmost main turret. So on the Yamato layouts, the main armament is somewhat more forward, and that potentially could cause more stability issues, all else being equal, simply because that means that between that and the narrowing hull form for higher speed, you're going to have those gun turrets, especially the forwardmost gun turret, A turret, that's going to be exerting all of its weight with a relatively narrow portion of hull to support it, both generally and in terms of roll and stability. So all other design considerations aside, I mean, even if you built the Nelson class, but with the turret layout and position relative to the length of the hull, similar to how the Japanese designed the Yamatos, or the Yamato predecessors that had the all-forward layout, you would have more stability issues than the Nelsons historically had. And that brings us to the end of the Drydock for this week. Thank you very much for listening, everybody, and I hope to see you again in another video fairly soon. Cheers for now.